Hi, I'm Goh Zee Xin. I will do the demonstration of Project 3. In Project 3, I'm doing 16-bit proof multiplier. So this one is my proof multiplier baseline, which is I'm using 3 register to store the shift value, and I have 1 register to store the proof code, which is from Q0 and Q1. And then I'm using separate adder and subtractor. So I will have 1 adder, 1 subtractor in this design. So I will get the end result or sub result.
And here, proof code will design which one is the result used. So when proof code equal to 0, 1, end result will be used. And when proof code equal to 1, 0, sub result will be used.
Then I'm using also 2 shifter. This one is the first shifter and this one is the second shifter. And then I'm also using 1 counter in the design. So in this design, during step 0, I will load the multiplication and the multiplier. Then I will do the addition and subtraction by getting the output of the code. At step 2, I will do shifting. So I will shift the accumulator Q and Q0. So the accumulator will be doing arithmetic shift right, and then Q will also be shift, and Q1 will also be shift. Then finally, when the counter is equal to 0, I will go to step 3. When go to step 3, then equal to 1, and the result will be the concatenation of accumulator and the Q. And finally, I will go back to state 0 to start a new cycle. So I will run it. So from here, you can see that when start equal to 1, I will start the state and start the start the count. So the count will start from 15 until getting 0. When start equal to 0, when the count is equal to 0. When the count equal to 0, I will get done equal to 1 and the result is equal to 50. So from the simulation, you can see that when count is equal to 1, that is equal to 1, so the result will equal to 50. And next, when multiplier is equal to -5, multiplier equal to 3, my that is equal to 1, and my result is equal to -15. And when multiplier equal to 32767, multiplier equal to 20000, I will get my answer as 655340000. Next is when multiplier equal to 3277, multiplier equal to -113, then equal to 1, I will get the result as -370301. Lastly, when multiplier equal to -30927, multiplier equal to -8021, my result will get 248065467. So it is able to handle negative sign and unsigned value in this design. Next, we'll go to the optimized design. So this one is my 16-bit proof multiplier optimized version. And here, I will directly using the adder and subtractor share unit and only using 1 shifter and use 1 tap counter. And I will use 1 only counter. So at here, we also have 3 steps. Step 1, we perform the adder sub. Step 1. So at here, we will also have 3 states. Step 0, we will get the input of the multiplication and the multiplier. Step 2, we will do the addition or subtraction. And then step 3, we will do the shifting. And then step 4 is give the done equal to 1 and pump out the result. So and here I will run. So as same with just now the baseline module, it will also decrease until the count equal to 0. And then I will get when done equal to 1. And inside state, after the state 3, go back to state 1. I will get done equal to 1. And then the result is get 5. And then, and same go with just now the baseline design. When count equal to 0 and after the state 3, I go back to state 1. And same go with the design baseline just now. After the state 3, I will go back to state 0 and if the done equal to 1 and if the result equal to 10 multiplied with 5 equal to 50. And then next, also the same, -5 multiplied with 3, we get done equal to 1 and at the state 0, we get the result equal to -15. And then 32727 multiplied with 20000. When done equal to 1, after state 3, I go back to state 0. My result is equal to 655340000. And then 3277 multiplied with -113. I'll get done equal to 1. Result equal to -370301. And then lastly, when -30927 multiplied with -x021, I will get the done equal to 1 and result equal to 24x065467. So the result is the same as the baseline and the cycle is also the same as the baseline. Just the optimized design have a better scheduling and because it uses less module, it share the module of adder and subtractor and use only one shifter. So that's all for my presentation for project 3. Thank you.